Night, everyone. So thanks for coming along tonight. Welcome. I'm Peter, the President of the Space Association, for a couple more minutes. Yes, this is not working. There we go. This is our May 22 meeting. Thankfully, we're meeting again in person, which is great. So I've just got a quick roundup of what's happening tonight, 7 p.m. Now. We've got a quick roundup of Space Association business and a bit of news. And we're going to run out of time with all the news that I've got, and also Angela's got a bunch of stuff that he'd like to talk about, so we might tap it on at the end of that. And then we've got our guest speaker, Dr. Michael Smart, with Hypersonix Launch Systems, and we're really looking forward to that. We tried to have that a couple of months ago, but the floods up in Queensland impacted the ability to communicate. So we're back on deck. We've got a lot of big news happening recently. And then we, if you're having trouble sleeping, we've got an AGM at 8 o'clock, so you're more than welcome to watch that. And 9:30, they'll throw us out. Well, we might be able to stay a little bit longer. Anyway, without ado, I'll get going. So we've got a space show. People may not know. It's a weekly radio show. Andrew Rennie, who's not here at the moment, runs that on Southern FM and also live stream. And also we have podcasts, which Michael Abdullah puts together. So this is our podcast channel there. People may or may not recall, we sent out a member survey a few weeks ago, and survey results have come in. I think Michael said we've got about 60% response rate, which is lovely, thank you. And so it closed on Friday. So what the process is going to be is the committee's going to take a look at all the results and have a talk about what that means, what we could do, what we could bring into what we're doing already, or what we're not doing, what we should be doing, how we're doing, etc. And we'll then come back to you probably next month and give you an update of where we're at, what we think would be the way to go forward. Now, the AGM's tonight, so if you'd like to be on the committee to be part of that process, we're more than welcome to nominate. So just putting that out there, if you're a member, of course. And Michael's going to give a quick summary of those results tonight, just an overview of numbers and all that kind of stuff. Once again, the Space Association is a non-profit group, just run by memberships, and we thank you for being a member, or if you're not a member, we'd like to have you, or if you're a current member, we'd like to have you come back and keep joining, we appreciate it.
It's a modest price.
It's a modest price, I've been advised, yes. So meetings, fourth Monday of the month, apart from December, the next one will be June 27. And once again, that next meeting will be June 27. So I'm just going to do a quick, can you give me some time? Okay, sorry, I've got to watch. So just a very quick spattering of space news. By the way, this presentation is being recorded and goes to our YouTube channel. So if I skip through stuff, which I probably will, and you want to go back and have a look, go to the YouTube channel, just go to the Space Association website, space.asm.au, follow the YouTube channel link, and we'll be up there. So there's a lot of interstate stuff happening, and it's not a lot happening in Victoria from what I can see. But New South Wales has set up a satellite manufacturing hub up there. They've announced some pretty significant funding for that. And so they're aiming to create 500 jobs. And did I just drop out there? Something's happening? No? Okay. And the federal government said it would invest 23 point. Is that dropping in now, guys?
Something changed.
Something's dropping in now.
Something changed.
Okay. Right. I thought it might be Henry Stroke. Yeah, so a New South Wales-led consortium wins a $70 million funding for a space manufacturing hub as well. And this is a consortium, it was over 10 years, and it's a consortium that just, I'm not doing them just dropping in and out.
You have to keep your head.
Yeah, right. So maybe that's it. Yeah, right, I'll do that. This is the big buffer speaking. All right, so I'll do that. So it's aimed to help higher value industries such as green energy, civil and marine sectors, etc. The University of Southern Queensland with a $550 million fast-track space tech manufacturing contract. So the coalition, remember those people that were in government last week? They announced it was investing $50 million. I'm not sure whether that's going to continue anyway. I assume it will be. To set up spark a new wave of homebred built technologies. So that's the University of Southern Queensland, innovative launch, automated, novel and automation, novel materials, communications, and hypersonics hub. Sounds pretty good. I think it'd be a big business card for that. And a collaborative hub will be provide research and infrastructure to support rocket manufacturing. And Gilmore Space up in Queensland, they've been tapped to launch a new sovereign-built surveillance satellite for the Defence Department. Interesting. They haven't actually spent anything in, well, very high yet. You know, they seem to be getting a lot of attention and a lot of funding. So it's part of a $15 million partnership using its Iris rocket and at an undisclosed location in Queensland. So I don't know. So they're also prepared to launch the first Australian-built rocket to low Earth orbit by the end of 2022. So you keep your calendars free. They're Bowen Spaceport in northern Queensland. Southern Launch, who we've had, we have Southern Launch on? Yeah, we have. They're friends of the association. They've been on a couple of times, I think. They secured some extra funding for their Wirraway spaceport, which is fantastic. And they did have 3 unsuccessful launches last year, but that wasn't because of the spaceport, it was because of the rocket and that was happening on there. But the whole structure of the facility seemed to work quite well, and they're continuing on. Rocket Lab, it's Australian space news, but we're going to claim Rocket Lab, right? They launched small sats and catches, but drops the booster. So you might have seen the Rocket Lab launched one of its Electron rockets and aiming to catch the booster for reflight using a helicopter. It grabbed it, but it managed to grab it, but as it came down, once the helicopter caught it at about magnitude 6 kilometres, 80 minutes into flight, mission control reported that the helicopter pilot sighted it. You can see a picture of there. Yep. And the light feed from the helicopter and showed the hook and the line, etc., waiting to grab it. 50 minutes in the mission, the stage and chute clearly floated into view, and the line went in for a snag. The hook, it attached from the helicopter, had to attach the falling booster and the parachute. However, it did detach and catch it, but it noticed that the helicopter elected to let go because it noticed different load characteristics than they expected. So I guess he wanted to ensure the safety of his helicopter, but apparently they did manage to retrieve the booster anyway after splashdown. So yeah, you live and learn, and they're getting there. That's pretty cool. Okay. Now, the Space Association has some of the best and most in-depth space reporters in the world, in Australia. And we have engaged a special news hound that we've engaged, and he's come through with some breaking news since the election. So this is our reporter here. And evidently,
Very credible.
Yeah, the Labor government's going to establish a space centre in Port Melbourne, and they'll be launching human beings into space. So look out. That's a mock-up, but it's pretty much going to look like that.
Was that in the election material?
I looked at, actually, I asked Andrew to have a dig into that. I couldn't find anything. So I think they're pretty bipartisan. On a serious note, I think they're pretty bipartisan with the space policy and developments announcements that have been going. So I suspect it will just keep on going as we were. So, all right. So global space news, just quickly. So Starliner docked with the ISS for the first time. Angelo De Grazia has got lots of information. He's going to give us a more detailed presentation, but I'll just give you a quick, speedy one because we've got time pressures. So the docking took place more than an hour later than scheduled because they had several issues. The docking ring had to be retracted and extended again, but it worked okay. Another issue was an off-nominal behaviour of a thermal cooling loop, and also a failure of 2 of the 12 aft-facing orbital manoeuvring attitude control thrusters. Anyway, they managed to get all around that, and I'm sure they're doing some investigation. And that's plane just stayed there until the 26th of May. So it should come down at 8:46 a.m. Australian time on that day on the 26th. So keep an eye out for that. So that's it, dock to the station. And well done, congratulations to them. So now we've got hopefully 2 viable, or almost viable human landing systems to get to the ISS once they get past this. Just a quick touch on the Artemis launch. So they're now planning an early June rollout for the SLS. As you probably will recall, they rolled it out to the pad, went for their wet dress rehearsal, which is filling it with fluids and propellants and pressurizing, and they didn't quite get there. It had failures and leaks and all sorts of stuff. So they made 3 attempts and then killed it all off and came back to the VAB to do some more work. So then now they estimate it would be June 18 to 20, and expecting a launch now in August. Once again, don't hold your breath, but anyway, we'll see. So the next launch window for the Artemis, they've got launch windows which sort of very much depend on orbital mechanics and all that sort of stuff. So July 26 to August 10, or August 23 to September 6. So these are all driven by windows of visibility and all that kind of stuff, achieving all the milestones of the Artemis 1 mission. So this is a...
I was going to say, there's no news on that slide.
Yeah. Excuse me. So this is a recently released mission availability document from NASA that I've got today. So 2022 and 2023, so they've got a schedule up to June. So there's a red where they can't, the green where they can, and the rest is not possible. So I think the red is they can do it, but they miss out some of the key objectives. So
what's grey?
Grey is just not happening.
Yeah,
Golf days.
Golf day, yeah. So for those familiar, this is the Artemis 1 sort of mission profile. It's going to go out into lunar orbit, and I think it's a retrograde lunar orbit. Some other great news, interesting news, is scientists grow plants in lunar soil. So researchers use small samples of dust collected during the Apollo missions to grow a type of cress. So in this, to their suppliers, they sprout after 2 days. So the Elisa Paul was very excited, and every plant sprouted. After that, day 6, differences emerged, and plants growing in moon soil started to show stress, developing more slowly, and ended up stunted. So not sure what that all means, but anyway, interesting. So yeah, they managed to actually get, I think, a gram of the lunar regolith soil. So pretty easy.
They asked for 3 grams, and the surprise when they received 12 grams.
That's what I've heard on the radio too, but this report came from NASA, so I don't know. Maybe there's 1 gram per, little cylinder. Maybe they miswrote it. Probably some teenage internet person that didn't understand what they're talking about.
I've never seen a media article that was correct.
Yeah, well, yeah, you'd think NASA would be at least half decent. Anyway, yeah, maybe it's 1 gram per little vial. Sounds more like it. Spacesuits on the International Space Station no-go for emergency sports, for non-emergency spacewalks after they have water intrusion. So people might recall they've got shuttle era EVA suits, and they have had problems a while ago, but then they had a problem back in March with one of the astronauts' helmets basically not filling up with water, but had a fair bit of water. Luca Pavatino. Okay. Oh, that was back in 2013. 2013. No, okay. I misread that story. But the pattern that had an issue back in March of this year as well. So either I've mapped that conversion up or something. Exactly. They had impaired visibility and breathing with water covering his eyes, nose, and mouth and ears. So obviously you can't just wipe it out of your face or whatever. So yeah, it's a very serious issue. You can't. Obviously you can't see, you can't breathe. It's real bad. So it's a close call, but they revealed that some clogs in the component that inadvertently diverted water into a vent line that allowed intrusion into the helmet. So they estimated after this spacewalk that 50% of the visor was coated with a thin film of water, and they have an absorption pad in the helmet itself, the back, for this very reason, and that was very damp as well. So they're going to send that EMU back to Earth shortly in July. All right, enough rabbiting on for me, and so apologies for skipping over, but there's so much news and so many things going on, but I've had to sort of just cherry pick a little bit. Without further ado, if you're ready, Michael, I will hand it over to you. And sorry.
Okay, yes, I am ready. I'll just turn my video on.
Perfect.
So,
do I just stop my sharing, Ash? So just while I'm doing that, Michael Smart spent 10 years as a research scientist at NASA's Langley Research Center in the Scramjet Branch. He's a pioneer in scramjet engine, hypersonic vehicle, and awarded Australia's top scholar in his field of aviation and aerospace engineering in 2020. And Michael is the vehicle and technology architect of DART-AE, Delta Velos Orbiter, and the Wirraway satellite launch system, which we'll learn all about now. So I'll stop sharing and let Ashley do his.
Thanks very much for the opportunity to talk to the association. I really appreciate that. As you've heard, my name is Michael Smart, CTO and Head of Research at Hypersonix Launch Systems. And Hypersonix it's a company that's fully Australian owned and is developing some hypersonic and scramjet technology here in Australia for the international market. So I might just give you a little bit of background about the company and where we are. And then I have a promotional video, which is actually I find really useful to show people. It takes about 3.5 minutes, but it's actually really useful to sit and watch. It's not quite Hollywood, but it's not too bad. And so I'll show that, and then I'll talk in a bit more detail about some of the technology. And then I want to make sure at the end there's plenty of time for questions. And I think if we wait till the end for questions, that's probably the most effective way for something that's being that's going to be recorded. So our company was formed in 2019, and it was to commercialize Australian scramjet engine technology, and in particular, but also hypersonic technology. There's been a long history of research in this area in Australia, funded by both the federal and state governments, mostly done at the University of Queensland, but also at the University of Southern Queensland nowadays, and also University of New South Wales. So there's been more than 150 PhD students graduated from Centre for Hypersonics at the University of Queensland. They're sort of spread out, not just in Australia, but all over the world. So I'm the CTO and the co-founder, and my partner, David Waterhouse, is also the co-founder, he's the CEO. At the moment, we have about 20 staff, but we've recently received some funding from the federal government, but also from investors, and we're growing to about 30. So, the company's growing quite quickly, and our focus is on the small sat launch market, which is tremendously fast growing. And our goal is to use hydrogen fueled scramjets to develop reusable systems for this enormous marketplace for small sats. And, and try to make it greener, of course, but also, our whole idea is that we fly to space like we're flying with Qantas, as opposed to being launched to space as if we're flying with NASA. So that's really our pitch in a nutshell. So I'll show this video. It goes for a couple of minutes, but hopefully it'll be enjoyable for you.
Space has always fascinated and inspired humanity. Now in the age of connectivity and information, we're taking to the skies every day. As the demand for spaceflight soars, so do the opportunities. We've seen more satellite launches in the last few years than the entire history of human spaceflight. With thousands more small satellites expected to launch over the coming years, and a projected market worth $10 billion, minimizing our impact on the planet is critical. This new era of space needs new, considered technology. Most space launch companies rely on non-sustainable launch systems, increasing pollution in our oceans and atmosphere. In the face of a rapidly growing market, this approach is not cost-effective, conscientious, or sustainable. It is time for change. It is time to fly to space. Hypersonix is pioneering the future of the industry through affordable, sustainable spaceflight technology. We fly to space using the Earth's atmosphere to soar like a bird. There's no need to carry oxygen. We're powered by clean, green hydrogen, so there are no CO2 emissions. We aim to be completely reusable, so you can rely on us over and over and over again. Here's how it works. Our Delta Velos vehicle flies like an aeroplane. Able to place a satellite in orbit from any launch site, it offers quicker turnarounds and more launch windows. Inside the Delta Velos, our Spartan engine draws oxygen from the atmosphere for its 5th generation air-breathing scramjet. Green hydrogen fuel provides thrust at 5 times the efficiency of any rocket, and its only exhaust is water vapour. The Delta Velos can accelerate from Mach 5 to Mach 12. With no moving parts, it's also inexpensive to build. The satellite launch process, like any space launch, is split into 3 stages. Stage 1 sees the boomerang boost the Delta Velos to Mach 5. True to its name, it then returns to where it came from. Delta Velos is Stage 2, flying to the upper reaches of the atmosphere under scramjet power. When the Delta Velos reaches terminal velocity, it launches Stage 3, delivering the satellite to orbit. Like the boomerang before it, the Delta Velos returns and lands on Earth, ready to fly its next payload again. While this may seem revolutionary, Hypersonix staff have been involved with scramjet technology since 1995.
After I completed my doctorate in aerospace engineering, I had the absolute privilege of working at NASA's Langley Research Center. My job each day was to think about new ways to design scramjets.
Our staff have proven flight heritage from the High Shot and High Five programs and have performed more than 6,000 scramjet ground tests. It's this knowledge and experience that has led directly to the foundation of Hypersonix and the creation of our reusable 5th generation scramjet made from composites. Hypersonix has been awarded a commercialisation grant by the Australian government and work with dedicated and passionate people at Boeing and BOC. By leveraging development in the growing hydrogen economy, we're providing a groundbreaking alternative to current technology. The Delta Velos prototype is under development. It will soon be flown to prove our speed, reusability and range. And the potential for Hypersonix technology extends beyond space. A clean hypersonic airliner, which could take you from Sydney to New York City in 2.5 hours, is on the horizon for Hypersonix. There is a global imperative to develop a sustainable green economy. Let's lead the way to the future and fly to space together.
Okay, so that's our video that we showed to lots of people, and it really covers the philosophy of the company and really what we're trying to accomplish by bringing a new technology to the space community. And it really is quite different to a rocket. So I'm not sure the audience how much you're familiar with scramjets, but essentially scramjets are air-breathing hypersonic engines. So hypersonic means traveling more than 5 times the speed of sound. So speed of sound is about 1,000 kilometers per hour. So 5,000 kilometers per hour. And the engines are air breathing. So we capture air as we're traveling along at Mach 5 or above. We mix and burn fuel. Scramjets can use a variety of fuels. At Hypersonix, we use hydrogen fuel. And so when the hydrogen burns with the oxygen in the air, we create steam and hopefully thrust. And scramjets have been, the idea of a scramjet actually has been around for more than 50 years, but it's only really in the last 20 years or so where the theory has come to reality. And there are different groups around the world flying scramjets now, and Hypersonix, we're particularly flying these hydrogen fueled scramjets. And you know, the reason a scramjet is better than a rocket for
Sorry, Michael, we're missing the very top of your screen. You might need to minimize the Zoom panel there.
okay. No, I can't see it either. Yeah, I'm sorry, I'm not sure how to change that. If anyone is familiar with Zoom,
Maybe stop and share the whole screen instead of sharing just the PowerPoint presentation.
oh, okay, right, right. Let's try again. Share screen. I had some options there when we practiced this, didn't I?
You may need to go to advanced because that was still sharing just there.
Yeah.
Still missing that bit.
So you can cut and paste all this, I hope. Yeah, the advanced options didn't really help me, but share sound, optimize for video clip. I did both those things.
All right, just maybe just click in your presentation, just get going.
Yeah. I apologize for that, audience out there. I'm sorry, we'll just have to keep going. So you can you all see the slide?
Maybe go back and forward one slide just so that it resets it because it's not drawing it properly.
How's that?
We're missing also a section on the right-hand side now as well.
Yeah, yeah. There we go.
Okay, well, we're back where we were, so just missing the top where the subjects are, so just make sure you read those.
Yeah, yeah. Okay, yeah, so the aspect of, yeah, so when we compare a scramjet engine to a rocket system, you know, for access to space, and if we look at the fuel consumption, it shows clearly what the advantage of a scramjet engine. So here we've got in the plot, we've got on the vertical axis is specific fuel consumption of propulsion systems, and the horizontal axis is Mach number. And so down in the left-hand corner, you've got jet engines, which are extremely efficient. So air-breathing engines use oxygen from the air. To the right, at the higher Mach numbers, we have hydrogen-fueled scramjets, which are particularly efficient, partly due to the energy content of hydrogen. And then if we go way up, we get up to rocket engines. And so the Space Shuttle main engine, which is, you know, the best possible rocket engine that you could ever design, is still more than 5 times more fuel consumption, has 5 times more fuel consumption or propellant consumption than a scramjet. And then, of course, the classic commercial rockets of SpaceX, Rocket Lab, and others, which use LOX kerosene, are even less efficient, so consume more fuel. And so you can see that's why scramjets can really have a powerful advantage over rocket systems. for access to space, and which is really about how much fuel or propellant you have to carry and how much payload can you put into orbit. So the particular scramjet that we've developed over many years here at Hypersonix was called Spartan. It's 5th generation, so there's been a lot of generations of scramjets over many years. And it has some really useful attributes when we think about creating like a product for a space launch system. It's accelerating. If you want to go to space, you need to accelerate. So our scramjet can accelerate from Mach 5 to Mach 12. So it can operate over that speed range. It's fixed geometry, so there are no moving parts in our scramjets. So unlike a rocket motor, which has, can have tens of thousands of moving parts, the scramjet that we've developed, Spartan, is fixed geometry, and we've done a significant amount of work there. And the thing that's enabled us to develop a fixed geometry engine is just understanding of the internal aerodynamics of hypersonic flow and flight. The system is also very scalable, so it actually gets the performance improves the bigger that it gets. We also don't have any ignition system required. It's self-igniting, and this particular engine is really the product of more than 6,000 ground tests in the T4 shock tunnel, which I'll show you in a second, which is at the University of Queensland. It's hydrogen powered, and we've done a lot of work in the company about being able to build these engines quickly and cheaply. And if the audience are familiar with the TRL levels, the TRL, the current system is about 5, and at the moment we've just received some funding to do a launch project, and so by the end of that it would be a TRL 7. So the reason that a company like Hypersonix is leading the world in scramjet technology is really because of a fantastic facility which is at the University of Queensland called the T4 shock tunnel. It was developed by Professor Ray Stalker at the centre, first run in the late 80s. I'll just run a quick video here. I hope it's not too loud. But it's this dynamic facility. It has a 90 kilogram piston that is accelerated down a tube, and then essentially works like a bit like a bicycle pump, creates very high pressure air, bursts the diaphragm, and once accelerated through a hypersonic nozzle can create the exact conditions that you would see in flight when you're traveling hypersonically. And so it's an absolutely fantastic facility, and it's really the crown jewel in terms of how we've been able to develop the scramjet engine here in Australia. This facility is also, it's the most productive in the world. There's been more than 12,000 hypersonic experiments in T4, and we've done more than 6,000 scramjet experiments. So it's really the basis upon which having a facility like this is the thing that enables you to lead the world in scramjet technology. Okay, now in Hypersonix, we're a commercial company, so we're really sort of developing a number of products, and the 3 products here, they go up in size and cost, just like many things. So the first thing that we're looking at, which we have funding for to fly, is called DART AE in particular, the AE meaning additive engineering. So we're going to use a lot of 3D printing to manufacture the DART as cost effectively and as quickly as possible. And DART is essentially, it's a hypersonic autonomous vehicle boosted by a rocket, and it could have a whole range of different missions. When boosted to Mach 7, actually has a range. It's a 3 meter long vehicle, so it's pretty small, weighs about 300 kilos. I'll give a bit more detail about it in a later slide. And it has a range of at least 1,000 kilometers, which is really tremendous. And it all comes from the scramjet. And so that's sort of our it's really our technology demonstrator for this scramjet technology, and also for the company to show that we can design, build, launch hypersonic vehicles. The next step up is what we call Delta Velos, which is the picture that on the intro to the presentation. And it's about a 6 meter long vehicle, hydrogen powered, but it's fully reusable. Has a top speed of Mach 12, and has a much larger range. And so the idea here is we have a reusable hypersonic platform, which could be used for a number of different things. Could be for long range travel of any kind, some sort of surveillance vehicle. Really has a lot of attributes which could be of interest to different parties. And then, of course, you know, the pièce de résistance, the thing that drives the whole company is this responsive satellite launch. So we call this Delta Velos Orbiter. It's about a 12-meter long vehicle, essentially a scaled up version of the demonstrator, 4 scramjet engines. The goal is to have it fully reusable more than 100 times, can change orbits, releases an upper stage to go to space as indicated in the video. And so that's really the commercial application of this technology. So there's sort of our 3 product lines that we're really working towards in sort of a slightly parallel, but mainly directed sort of way. So what are we doing right now? So we recently completed an accelerating commercialization grant for the Department of Industry. We received that about 2 years ago, and that grant was to build a hydrogen fuel system for our scramjet, but also to build a prototype scramjet. And you can see the team there. That was taken the day when we're doing some testing. I'm not in there. I'm not. I don't get to have the fun. I get to do all the other things. But we did some hydrogen testing there, where we did what's called hardware in the loop testing of our hydrogen system. So we have the real valves, the real software, and we drive the system as if we were doing a flight. And as also part of that program, we 3D printed a scramjet engine. Now it's shown at the bottom there. That's our Spartan scramjet. That engine is about 2 meters long, fully 3D printed in Inconel, which is a high temperature nickel-based alloy. And it is the engine that we will fly on DART. And we've been able to manufacture that in Australia. A company called Amiga Engineering in Melbourne manufactured this engine, and they did an absolute tremendous job on it. And so this is a project that we've been working on over the last 18 months or so, and it's just really come to completion. And we're very happy with the results of that. Now, the next thing we're working on is a flight test of this DART AE, so the multi-mission drone. And some of the specs are given here. So the idea is this vehicle is boosted on a sounding rocket up to about 40 kilometers altitude. We then separate from that rocket, and then we do a controlled trajectory. So this is a fully autonomous vehicle, would fly a scramjet powered trajectory of up to 1,000 kilometers. It's 3 meters long, so it's really not particularly large. And we have a 30 kilogram payload. And so right now our team is building up to 30, as I mentioned. And the reason we're building up the team is to actually go and do this flight. Now, we're a scramjet and hypersonic vehicle company. We're not a rocket company. So we actually have a partnership with the rocket service provider to do the boost for us. And that's a partnership that will go forward because our company, you know, recognizes what it's good at, and it also recognizes what's very, very mature technology that doesn't really need another rocket to be developed in this particular case. So we're working with a couple of different partners to see what's the best way forward for that. So that's the DART AE is the project that's really the focus of the team right now, and so we are progressing towards a launch. You know, it's probably going to slip into 2024 now, but our goal was 2023. And then so our third product is the reusable rocket launch, and sorry, the reusable small satellite launch. And I just wanted to reiterate some of the issues that we're trying to deal with here. So we call it old space, basically highly polluting rockets that, you know, are thrown away every time they're used. So there are a lot of problems with this. You know, there are long waiting times. That's getting a little bit better now with different players coming into the market. There are two different aspects. There's a ride share where you would take a ride with a whole lot of other people, but you all go to the same orbit, and hopefully you're all okay with that. The other way to go is dedicated launch, where you're the only customer on a particular launch, but it's seriously expensive. And it always has been. And guess why it's expensive? Because you throw, it's just so old-fashioned and so polluting. And when you do that, you end up with these long supply chains for these rockets, like enormously long supply chains. And if one part of the supply chain falls apart, well, the rocket launch is delayed for a couple of weeks or months or whatever. And another final thing is these rockets are basically point and shoot devices. So they have very rigid flight planning. And so that's the current state of play. So when you think about a system like ours, which is essentially based around a hypersonic aircraft, it really does change the whole paradigm of what launch is. So this is a picture of the east coast of Queensland. I've got the typical, commercial flight corridor covered there. We have our launch site. It's at Rainbow Beach, which is actually a very lovely part of Queensland. That's just one of the places that we've been thinking about. And we're thinking about doing a launch to a sun-synchronous orbit, which is essentially northerly. So if you had a standard two-stage rocket, you'd have to launch directly north, and you'd have to dump your first stage somewhere north of you, which in this case, is essentially the Great Barrier Reef. And also, you're flying in the commercial flight path corridor. Now, with a maneuverable aircraft, we can actually launch easterly. As you can see there, the red part of the trajectory is the boost. The orange is the scramjet acceleration, and then the upper part, the light blue, is the third stage. So we can do a full maneuver of this system. And the economic benefits of that, I just don't think the community's really thought about yet. But it's really going to be a big thing going forward, is the flexibility of launch. If you're going to launch 50,000 satellites in the next 10 years, you don't want to have to be sitting there waiting for launch corridors to open up all the time. And then, of course, the green trajectory shows how we fly back to base and land horizontally. So you can imagine that you have access to a lot more different orbits from the same launch site when you launch this type of system. So it's really just, these types of ideas, we're just trying to open up the mind of the community, the space community. Okay, so that sort of covers everything that I wanted to say, and I'm really interested in the questions. But I just thought I'd show a picture of our team. So we have David and myself who run the company. Gary Lewis is one of our directors. We have an advisory board of lots of greybeards. And we also have, just recently, we've brought Trish White on as one of our directors, who's a fantastic technologist, Adelaide-based technologist, who's going to help us out with things. And then, of course, we have the team that get things done. And as I say, we're planning to increase the team from 20 up to 30 in the next very short period. So I'll finish there. So should I stop sharing there?
Yep, you can stop sharing, and I've also allowed people to unmute themselves. So if you want to unmute yourself and talk, you can. Peter, you're
I'm not
muted.
sure how long we have, but I'm very happy to answer questions. It's a really different way of thinking about space. So I'm happy to answer any questions that you have.
Hi, Michael, it's David Boyd speaking.
Hello, David.
Thank you for the presentation, and it's great to see hypersonics progressing after a long time in Australia since those launches out in Woomera many years ago. I'm curious about the amount of funding you would need to get to a point where you've got the final satellite launch configuration, which is your own hypersonic vehicle plus a recoverable booster first stage, because that's a really significant investment in its own right, and it's something that only SpaceX has achieved so far. Rocket Lab hasn't yet. So it's a big thing as well. And I know you've got many milestones along the way, but I'm just curious how you'd see that unfolding, that bigger picture of gaining the funding, perhaps in Australia or overseas, all that venture capital stuff, that kind of thing, or whether that's too pie in the sky yet to even consider.
Oh, no, thanks a lot, David. No, it's not like we're a commercial company, so we have a business plan to get to fully commercial launch. And we've actually done a lot of looking at other companies, small satellite companies. So we're talking about small satellite launches here, the order of 100, 150 kilos. And we've looked at the funding profile for each of them. And it's sort of interesting. It basically takes about $100 million to develop a small sat launch system, rocket-based. And like all of them that we've looked at, there was, Falcon 1, which is the start of SpaceX, and then there's Rocket Lab, and there's a whole, there's 10 serious groups in the States, and, and there's 100 others. So that's really interesting. With us, we're expecting an overall cost that's fairly similar to that, but we've essentially already had $70 million invested in this technology in Australia by the Australian governments, essentially. So based on our economic predictions of the cost to get to that system, we're hoping that it won't cost us another $100 million. Our technology is very mature. We're going to take advantage of rockets where we need them. So you mentioned our first stage booster. The difference between that and, say, a Rocket Lab first stage is we're only boosting to Mach 5. And when you saw that trajectory there of our system, the booster, it's a relatively small rocket. Getting it to fly back, the fact that we're only going to Mach 5 really helps with that as well. Some people in the audience there may be familiar with how NASA has looked at flying back rocket boosters, for example. And the key thing with doing that is Mach number. So if your first stage boost has to go to Mach 10, it's virtually impossible to fly it back to the launch site without another propulsion system. But if you only been boosting Mach 5, it actually makes it much more doable. And we have done quite a bit of work on the flyback booster we call Boomerang, but in the last 18 months, 2 years, we've really had to concentrate on the scramjet work. And so we'll revisit that as time goes on, because like when you have a small company, you've got to really focus on the key product that's going to generate revenue. And that's different, that differentiates you from other companies. And so we've really concentrated on the scramjet. But you're quite right, it will take a good amount of funding, but we're not going to develop our own rocket, for example. We will partner with an existing system. We've talked to many of them, and we will partner on the rocket booster side of things.
John, you can talk to the camera, Evan. Just check. We're in the room here, Mike. Can you hear us?
I can see you all there. Yeah.
John Coleman's going to ask you a question.
Okay.
My question is, what sort of nitrogen oxides are you going to get in the exhaust from the scramjet?
There's a little bit of NO generated, but it actually depends a lot on the details of the combustion, and so we will, attempt to minimize the NO, but it's trace amounts of NO to be generated. But it is something that we do need to consider, because we don't create any CO2, so there's no problems there. We also fly quite high altitude, so between 25 and 40 kilometers altitude. So there's nothing else that really flies up there. So we're not contributing to the NO that's produced by commercial airlines.
I'm not a scientist. I will confess straight up, and it's probably a stupid question. the Concorde used to have problems with the ozone layer or something back when it was flying. Is there any impacts on the upper atmosphere from a hypersonic vehicle?
You know, as I say, there are aspects to be investigated, and you know, if we're flying 50,000 of these per year, then you know there could be some environmental aspects which would need to be managed, definitely. But we're a long way from that, and we also create significantly less pollution than in any rocket system, for example. So it's definitely an improvement on a traditional rocket system.
What's your upper stage going to be for getting from Mach 12 to low Earth orbit speed?
Yeah, so we've looked at it. You know, we won't develop that motor ourselves. We've looked at a couple of different options, some from the prime, some from smaller companies. But it'll be it's the only part of the system actually that's not reusable at this stage, because it's quite small, but it's such high speed, and you know, ends up being orbital speed. Bringing something back and retrieving from orbital speeds is really difficult, and so we're not planning to retrieve that. But there are a number of options. As I say, it's amazing how many companies out there have little rocket systems. I think for us, the question is going to be, you know, which ones have the best track record, and you know, all those other things. So we'll choose our partners wisely, but we're planning to choose a partner to develop that for us.
How hot does your rocket get when it's traveling at Mach 12?
Quite hot. So the Delta Velos Orbiter will be manufactured from high temperature composites. They're called ceramics matrix composites. They can operate at around 1500 degrees C and not be damaged in any way. So they're really unbelievable materials. There will be a couple of spots on the vehicle that get even hotter than that, and we have like more ceramic type materials for those spots, and also tungsten. We use tungsten a little bit as well, good old fashioned high temperature material. But yeah, it like that Delta Velos, it will be white hot when it's flying. You know, you wouldn't, if you're flying at Mach 12 beside it, you could not look at it. It would burn your rifle. Be serious hot. And these materials are quite amazing. These ceramics matrix composites, they've been around for probably 15, 20 years, but they haven't been able to be manufactured in useful components. They're more just like flat plates. But nowadays, we actually, at the moment, we're having one of our scramjets, or like a representative scramjet manufactured from these CMCs, they're called.
Michael, we've got an AGM coming up very shortly, so if there's one more question in there, we'll do one last question if you don't mind. We'd love to talk for another hour, but we've got this obligation to get this meeting done. Apologise.
Yeah,
Question? There was one online that came up.
Yeah, there's a question online. Where are you planning to launch them from? Queensland or another state?
Yeah, so at the moment, it's unfortunate that in Australia, the launch regulations are not very mature. I'm sure you guys mentioned that you had Southern Launch come to talk to you in the past. They're working really hard with the agency to try to develop all the regulatory system that we will need to launch in Australia. And in the longer run, we will launch from Australia, but most likely, it's not set in stone yet, but most likely we will do our first launch from the US. And the reason for that is, you know, we're a small company. We need to focus on our core technology, developing the regulations for for space flight in Australia. You know, how long is a piece of string? How long is that going to cost to develop, and how long is it going to take? So we've had to make the decision at this stage to go and launch in the US. And it's just for expediency. That's the entire reason, to get to launch quickly.
Excellent. Well, once again, I do apologise for not giving you more time. We'd love to. Under normal circumstances, we would, but we've just got this obligation. perhaps we can get you back in a month, 6 months time and give us an update of where you're at. That would give you a bit more of a expanded opportunity to tell us what's happening and more.
Yeah, and but by the end of this year, we will have really determined where we're going to fly from, and we'll have some hardware already being built, and so that might be a good time, or early next year.
Maybe we might go and visit that factory in Melbourne and have a see what they're doing.
Yeah, Amiga Engineering was the company that manufactures. Fantastic company.
All right. Well, thank you so much. We really appreciate you taking time. I know this was the second attempt and you had issues, so thank you for doing that.
Thank you. Thanks for the opportunity.
Pleasure. You're more than welcome to start and watch this meeting if you want.
And I'm going to have some dinner.
Good.